All right, so in this lesson, we're going to write, I should at least use a different color. So we will write the we'll say the equation of a line parallel to another that goes through a specific point. So I guess that goes through a specific point. So we're going to write an equation of a line that's parallel to another and it goes through a certain point. So let's find out about some parallel lines. So line A, so this is line A right here. So line A, and then we'll put line B. So line A, 1 over 2x plus 3. So plus 3, 1 over 2, 1 over 2, 1 over 2. And line B is f of x equals 1/2 x minus 5, so minus 5, 1 over 2, 1 over 2, 1 over 2. Parallel lines. So this is a pair of parallel lines. Let's look over here. Here's another pair of parallel lines. Line A, line B, or linear function B, linear function B. If you notice, these are also parallel. They don't touch. These don't ever touch. If it was slightly leaning that way, then they would eventually touch. It might be all the way over here, or if this one was like slightly leaning, it would touch over. These would touch over here, but these never touch. Like railroad tracks, never touch. But why? They start at different points. If you can see, they start at different points, right? Plus 3, minus 5, plus 1, minus 4. They have different y-intercepts. But the reason why they never touch is because they lean, they slant the same way. They're slopes. If you notice, like this 1/2, this is 1/2. This starts somewhere else, and this starts somewhere else. But if they go up 1 over 2, up 1 over 2, up 1 over 2, they will never, ever, ever, ever touch. So let's look at these. So this is negative 2 over 3, negative 2 over 3. So even though they start at different values, their y-intercept is different. They both go down 2 over 3, down 2 over 3, down 2 over 3. So every time this one goes down 2 over 3, this one goes down 2 over 3. So they never ever touch. So what do parallel lines have in common? What makes them parallel? So by definition, parallel lines have the same slope. So parallel lines have the same slope. So I'm going to same. Oh, I can do that a little better. The same slope. All right. So let's look at these pairs of lines. So these two lines are like railroad tracks. They never touch. So they are parallel. The reason why they are parallel is because their slopes are the same. The constant rate of change is the same. Example number 2. These are not parallel. They touch right here. So these are not parallel. The reason they're not parallel is because this one like goes up something, right something, up something, right something. This one just actually doesn't even go up any, it just goes right. So the slopes are different. And right here, they look like they don't touch. They don't touch within these bounds, but they eventually do, like back here somewhere, like if I continue. Or maybe not that soon, like somewhere over there, right? Like somewhere over there. So these are not parallel. Their slopes are different. All right, let's use this. All right, so this example reads, what is the equation of the linear function? So what is the equation? So we want to know the equation. What is the equation of the linear function that is parallel to? So that's parallel to the line f of x equals 3 over 2x minus 1 and goes through the point -4, -9. So what's the equation of the linear function that goes through this right here? So let's graph this. So we want to know, well, let's back up. We want to know the equation of a line that is parallel to this bad boy right here. But we don't even know what this looks like yet, right? So let's go ahead and just graph it. So -1, go up 3, right 2, 1, 2, 3, right 2, 1, 2, 3, right 2, 1, 2, 3, right 2. Okay, down 3, left 2, down 3, left 2. Okay, I'm gonna leave this like this for now, because if I try to draw the line, it might not look parallel. So I want this other one to go through -4, -9, -4, -9. Cool. It needs to be parallel. It needs to never touch this line, never cross it. So it needs this 3/2. So 1, 2, 3/2. 1, 2, 3/2. 1, 2, 3/2. And so on and so forth. So I will attempt to do this. So my original one goes like this. Okay. And the line that's parallel and goes through -4, -9 goes like this. And you can see that they never touch. Never touch. Never touch. They never touch. They are parallel. So I will actually label this -4, -9. And so we need to write the equation of this line. So 0, -3. So f of x equals, you could also put y if you want, -3, 0, -3. So -3. And what made it parallel is that it also went up 3/2. So 3/2. And don't forget your x. So let's do it like this. So -3, and then it went up 3/2. Cool. Now let's figure out how to do this if we didn't have a graph, right? So I'm going to write my original, well, I want it to be y equals mx plus b, right? But I know it's parallel, so it has to keep this 3/2. This has to be the same. But it needs to go through -4, -9. So -4 is the x. I'll write right here. -4, -9. Remember, that's the x and y. So -4 goes right here. -9 goes like that. -9 goes right here. And then plus b. So a positive times a negative. Well, let's just write this first. A positive times a negative is a negative. 3 times 4 is 12. 12/2 is 6. Plus, I've got to make this look really like a b. Okay? So -12/6. Wait, how did I get that? That's weird. I don't even know. Oh, I know why. So negative times positive is negative. 4 times 3 is 12. Divided by 2 is 6. And then plus b. So I add 6 to both sides. -9 plus 6 is -3 equals b. So b equals -3. So I have this right here, 3/2, and I have this b right here, which is -3. And I have, so it should be f of x equals 3/2 to make it parallel, x, and then -3 to make sure it goes through -4, -9, -4, -9. Let's do it again. Okay, so what is the equation of a line that is parallel? So what is the equation of a linear function that is parallel to the line f of x equals negative 4 over 3x plus 8? And that line also goes through 6, negative 10. So let's graph this one first. Negative 4. Negative 4. Oh, that's not even right. 0, 8. 0, 8. And it goes negative 4 over 3, so down 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Okay. And this other line is parallel. It goes through 6, negative 10. So 6, negative 10. And it's parallel, so it goes down 4. Now, I don't want to completely get this wrong, so I'm just going to go this opposite way. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay, cool. And, well, let me write that down first. This was where 6, negative 10 was. And this y-intercept is 0, negative 2. So the equation of our line is y equals, we have this minus 2 over here, and this has to be negative 4 over 3 also. That's the equation of our line. Oh, that doesn't look nice. Okay, so what if we didn't have this? Well, let's find out. So y equals, oops. So we would have y equals mx plus b. Remember that we want to keep this same, slope. But we want to use this point, 6, negative 10. That's x and that's y. So that's x and that's y. Okay, so we have negative 4 over 3. And instead of x, I'm going to put 6. Instead of y, I'm going to put negative 10. And we don't know what b is yet. So let's multiply this out. Negative 10 to positive is a negative. 4 times 6 is 24. 24 divided by 3 is 8. And so that you put plus 8 here, plus 8. So b equals negative 10 plus 8. 8 minus 10 is negative 2. And remember that we're using this slope and this y-intercept. So y equals negative 4 over 3 x minus 2. And that is it. Thank you.